Welcome, welcome to Lively. I hope you all are comfortable and grab some water to drink because it's quite hot. My name is Peter Peerdeman. I'm the lead technology of Lively. We've recently started working with Meteor, so I'm very glad to show some of the stuff that we encountered during our adventure working with Meteor. So it's Meteor, a production story. Happy to announce that a product will be launched in the end of July. So you will all be invited to participate and check out Startup. First, I wanted to talk a little bit about Lively. We're a web agency here in sunny Amsterdam with a team of 10. We got a development team of 6 people. We do mostly web applications. We came from a concept and videography background, so you can see Nick in the back taking the video as well. And we try to really think of innovative solutions that help our customers solve a problem. And we love to use interactive web applications to solve these kind of things. All right, so basically I'm going to talk about Startup. Startup is a startup which is a smart marketplace for teamworks, matching people into temporary teams. Just let it sink in for a second. So the idea is that you have multiple organizations, could be companies, could be non-profit organizations, could be a group of freelancers or even volunteers who are willing to work together to do a project. So Startup facilitates the matching of getting a project out there, so explaining what project you want to complete and getting the people in there. So maybe if this sounds a bit fuzzy, I'm going to give away the demo immediately. So here we have the start of the web page. So everything is built in Meteor, running on Modulus. I'll get on this topic later in the slides. All right. So the idea is, for instance, we have a Startup over here, which is about organizing this meetup. So we actually use the product to do some of the planning for this meetup. So we can click on this one, and we can actually see that there's a big timeline which basically shows all of the activity that's going on inside this group. So basically, when you want to start your own Startup, should have probably put it on English. I don't know anyone understands the Dutch language, but we'll just leave it for here. So we can create a Startup, give it a name, and add some activities, so some activities that have to be done. And when you go to the Startup activities, you can say, I want to do this, or I know someone who is able to do this, so you can invite other people inside this temporary team with a fixed deadline to complete a project. So that's basically what we did. We had a lot of focus on user interaction, so it's a very rich interface in which you're able to say, well, I want to be able to do this. I can say I've only got a couple of hours in which I can complete this activity. So maybe it will be a collaboration of multiple people pitching in some hours or pitching in some money. Of course, the rating system is very important, so you're able to rate each other's activity. And of course, this is all reactive. So if someone else is currently on the page, you can actually see that they're online immediately, and changes as they occur when people are reacting to your messages. You will immediately get like something changed, and you can automatically see that you're actually collaborating to complete this Startup. All right. So I wanted to talk a bit about how we started this project. Maybe a quick round. Who has ever worked with Meteor before in the room? Who is a bit like excited to start with a next big project in Meteor but doesn't quite dare to do it yet? Everyone dares to do this? No, nobody dares to say it. Okay, so I'll just give a little insight about why and how we chose for Meteor and how we kind of argumented our way into using this awesome framework. So the promises for the project were, we have to have a super quick launch. So it has to be live in 4 months, it needs to be ready, it needs to be slick, it needs to be a good concept, it needs to be able to withstand some users, and it should be done pretty quickly. So that was one point that got us thinking. There was an emphasis on real-time collaboration. And if you try to do this in like the old infrastructure with RESTful interfaces, and we had a lot of experience in Angular, you would have to do a lot of polling and making sure that you're actually getting push data or actually pulling data frequently. So this was one of the points that made us think about Meteor as well. It has to be easy onboarding for developers, because there will be a team being built up that will actually take over the project and that will continue on to work. So there needs to be good documentation, needs to be accessible, and needs to be, well, easily understandable for people to get into the project. This was mainly the premises that we had. So basically we went for Meteor and we got a couple of goods, bads and uglies. But mostly the goods, of course, were the important parts. So we, of course, had the reactive data model. So once you start getting your data, you will actually subscribe to a source and actually get the data pushed to you. Who already knows this kind of stuff? I'm just curious to how many people already know about like everything from Meteor. Okay, then I'll glance over it quickly. So the reactive data model is important to get your data. For us, it was very important that it was an all-inclusive development environment as well. This bridges the gap between the front-end developers and the back-end developers, which was a very nice pro for us, because everyone is able to do a little bit of everything. Of course, you will still have your specialties, but we're seeing now that more times someone who is specialized in front-end is able to do something in the back-end, or at least communicate more clearly with people in the back-end to solve a problem. And there's loads of modern packages. So even though it's quite new technology, there's already like a lot of features, like the user status that you saw, that someone is online or offline. This is basically almost like one-liner packages that will just install and rapidly accumulate features in your application, which was, for the short time span that we had, was really welcome. Yes?
Can I have a question?
Yes, definitely.
When I tried to search for packages, I found it kind of hard.
You found it hard?
Yes, I mean there were a lot of packages and I just didn't know how to search for packages and what did they do.
Yeah, that's a very good point. We also had this revelation, so I think this is something that's common between everyone. So basically, well, you don't really solve this problem, but it's just dipping your foot into a lot of places where people are talking about packages. So I'm constantly listening to like podcasts about Meteor, visiting all of the Meteor meetups. So people tell about their packages and tell each other, this is what we use, or this is something someone else uses. So for instance, we were starting out with forms, and we thought, oh, there must be someone who did this. So the mighty old Deed stood up and gave us the outer form, of course, but it's mostly almost mouth to mouth that we actually find out about these good packages. Yeah. But it really helps to jumpstart development. All right. So I split it up between the good and the scary. So the point that we came across, the framework maturity, which is an exciting point. So I would guess for more of corporate organizations, it would be very exciting to use something that just launched 1.0 like a couple of months ago. So version 1 of Meteor was just out. So this is it's quite new, and of course it's very volatile. A lot of things are happening, and you need to be on top of the release schedule to make sure you're up to date with the latest version, because there's sometimes breaking changes, and there's a lot of stuff happening in the development. But we have a strong belief that the foundation is good enough to actually get your product started for a production version, as it is now. So we had some previous experience with, myself had some previous experience with Meteor from, I think, 0.5 or 0.6 or something. And when it was still a bit flaky, and maybe even more the beta version before. So it was a nice proof of concept, but as I'm looking at it now, I find it to be stable enough for real production stuff. All right, so risk tolerance is the thing that automatically rolls out of this, right? So how tolerant are you to this risk of stumbling upon something that you need to solve in a little bit different way? I mean, Meteor is built on top of Node.js, so this was a fallback for us as well, because we have written some applications in Node before. So this was for us at least a safe fallback to know that if there's something that we really need to do outside of Meteor, we can always create like a piece in Node, and you could even create your RESTful API on top of DDP if you're not able to do the things you want inside of Meteor. So for this particular project, we were very lucky that Peerdeman had faith in us that we would be able to deliver with his framework. So yeah, it's a wise choice. All right, and the third part is DDP, which is kind of scary. Everyone knows what DDP is? Hands for DDP? Nice. All right, so protocol is a bit different and new. Also, I'll get to this in the end as well, but what's... Sorry?
Is that exciting?
Yeah.
What's scary about new things?
So maybe I thought more from a perspective of someone... Yeah. Maybe we thought more about a perspective of someone who
Like company investing.
Yeah. It's maybe more from a... Huh?
For me,
It's basically for Rolf. Yeah, I wrote the slide the wrong way around, huh? Yeah. Maybe this was also part of like the sales conversation or the business conversation we had behind choosing for Meteor. Because of course we all find it fantastic, and very glad of this. All right, so there's a couple of challenges. Probably you guys have also seen some challenges. We'll get into some code as well. So basically teamwork at Lively. We have a team of 6 people. So people have to work together. So we use Git for versioning. But of course, the Meteor tutorials basically always say, tutorial says, put everything in one file. And you'll find more often than not, you'll find any example on the internet is just one big HTML file, one big CSS file, one big JavaScript file with just basically everything in there. And of course it makes sense because Meteor will automatically build all of your JavaScript into one file anyway, and it will serve it to the client. But working together in just one big file will get you a lot of issues with versioning control, and will in the end really bite you in the ass when you want to have multiple teams working on your project as well. So we started looking around for some more structured way of putting the files apart. So I would like to share with you our holy grail of a project tree structure. So basically, when we started out, I did some research to this, and there's a couple of groups of people. Some people that say, okay, we do everything inside the application, and we just include some third-party packages that will have some extra features, but it will be one big folder with smaller folders in there for modules. But I also saw a very interesting blog article about one article and another article that talked about these packages, because this was new in, I don't know which version of Meteor, but a couple of versions back. They introduced like this whole package system, which is now also on Atmosphere, so you can easily include your own packages, but actually creating your own packages within your own application is very easy to do now as well, and really separates out these pieces of functionality. So what you can basically see here is that we have the main application folder. So beneath the application folder, there's some backups, the binaries, configuration for your local development. We have some DevOps stuff to deploy to the servers. And of course, some documentation. But the fun always happens in the app folders, right? So we have a client folder that we're actually very proud of. It's very empty. We have the IHNN, which does some of the translations that were still left in the part before this refactoring, so it's also practically empty. Lib folder also empty for, I think it's still empty. And we have everything in packages. So you can see over here on the top we have all of the client packages, which are basically like small widgets on the page, widgets or components or just small pieces of functionality, which is really matches up with React philosophy. Any hands for people who know or use React? Not everyone at the same time, okay. Which is this philosophy that you basically have a component that listens to data, reacts on data, and feeds back into the data, so you won't have a lot of state. So we thought it was this approach was pretty cool. So we basically split up all of the application parts into separate packages. So basically, if you would take this one step further, you actually have every package could have its own life cycle, and you could have your own team working on some package, completely separated from the rest of the project. So we have a lot of these small components that you actually see in the UI. So the activities, the contributions inside an activity. Then we have a couple of different packages, which is the pages. So you still had to have some routing, right? So you need to have, when you visit a route on top, you need to be able to decide what components will be rendered on the screen and which data should be loaded inside these components. So we still have this idea of pages, which would correspond to the routing in the URL. And these pages basically load in these widgets, but I'll get to that in a second. Then we have the library package, which is basically the package that will be exposing stuff to both the client and the server. So this would be the place for the polymorphic code, which would be the code that would be loaded both on the client and the server using the same code base. So for instance, the schemas for our validations is used on both the backend to check the data that's coming in from clients, but it's also used on the client to, for example, display there are 120 characters left inside this field. So that for us was a very convenient way to be able to make sure that we don't have to constantly match these values.
Can I ask a question? So
Definitely.
You have like the part of client rating package,
Yeah.
and you have the part of lib package.
Yes.
Does the lib package contain the schema for the rating?
So we thought about doing this, but the answer is now no.
So the schema is inside of the client rating package?
The schema is now inside the lib package.
Okay.
Yeah. So we grouped it in there. So we thought about dividing everything up, but we found that we have a lot of shared use of certain schemas as well. And this would mean that if we would, for instance, have, say, for instance, creating a new product is a form and just ask some fields, but updating a product in a smaller widget would actually use the same schema.
Yeah.
So where would you then leave the schema? So this was constant questions that we had as well.
Yeah.
Yeah.
Okay.
And then we have the server. So we have a server package which would contain the server-only code, and this is also separated. All right. Any more questions on the application structure? Is there someone who used this package structure before? I'm really curious if there's someone. Yeah.
Don't you like have the problem that you have to add every file that you write? you have to edit in the
Yeah.
package.js.
Yeah.
Did you find some magic to make it easier, or
So for the SCSS files, if you use SAS, they will actually be automatically added. But that's like a feature in the complete package, so that's not really fair, right? They just add the line to the file. But yes, this is both the downside and an upside, because you have real tight control over which files are included on which on the client or the server. But it's true. Sometimes this is quite annoying when you rename a file and then you have to rename it inside the inclusion file as well. Yeah. All right. Oh.
Have you tried different structures for the routing inside the package, the shared package you have?
So the question is, if we try different ways of routing.
Yeah, and making it less
A bowl of spaghetti, less of a bowl of spaghetti. Yes, actually we did a refactor recently in which we moved all of the subscriptions from the routing file. So basically we had an iron router file in which you would have, you go to /startup/ID and you would subscribe and then load the page. So we moved this to just include the ID and give the ID to the package. And now the package itself is responsible for getting the data, which makes sure that once you render a page, there will never be too much data loaded automatically. So that's the two approaches that we had. Cool. So maybe dive a little bit deeper inside the component directory. So we had all of these directories that you saw before. So split up in i18n files. So I didn't mention it explicitly, but one of the premises as well was that everything had to be translated. But I always like to have slides with just 3 things on them, so I left it out. So all of the translation files are per activity, which is sometimes for the people that have to translate, it's a bit more work. Ralph is smiling now because he has done a lot of these, gets a lot of translation files from us, but it mainly also keeps you from getting like one big translation file in which you completely lose what you are using and what you're not using.
So now, for every pack, you have a lot of redundancy, right? Or wrong? This is one, if you have the same translation,
Yeah.
you have it all the time.
Yeah. Yes, you would have this redundancy, but we've actually found that there's not a lot of redundant. There's not a lot of redundant stuff. So our copy is very specific for the situation. So I thought about this before, and you would have like a couple of buttons that say yes and no, right? And yes and no would be in multiple places. But we found that there's really little overlap actually of the labels so far. Yeah.
Do you agree?
Yeah, we have a very specific copy, so every button has a different way of saying yes.
Yeah.
So this is it's an ass, but it works better.
All right, so basically I'll just skip over the templates for a second. We have the main entry point, which is the activity.html, which basically defines the template. We have the activity.js, which is the entry point for the JavaScript. So this is the place where the stuff gets included. Then we have a file that has to be there for translation. Don't ask me about it. And the package.js basically says which files are included and will actually show which files are included on the server and which ones are included on the client. So because we have both the create view and the edit view for this component inside the same widget, because they do almost the same thing, we found that we still split up some of the functionality inside templates. So this is why we have the templates folder over here, which has its own HTML and JavaScript files for the different views of the widget. So this would be, maybe if I show the activity, so you're actually able to create an activity. Present at the meetup. So if we have we are now looking at the view part of the activity, and when we go into the edit mode, we'll actually show the edit form, but it's still the same. It's still the same component. Just give me. No, that's okay. Let's go back. So basically, the HTML file that I was talking about is the entry point of the component. It's basically defining the activity, and basically there's just this big if statement of whether we show the form or whether we show the view file. And you can actually see a little bit of the magic happening over here. So the templates get passed all of the data that's required for this sub template. So basically, we use these APIs to get the data from the route into the package, and from the package into the components that are nested inside this component. So here we have a show form helper, which I have on the next slide. So the show form basically says if you passed in a value that it's a read-only, not read-only, or we have the edit. We have the edit variable set. It will actually render the show view or the edit view. All right, and you can imagine that the activity form itself has more of the logic about the form itself and the view buttons. But this is the component API that we define in this way. So for us, it's very nice that we have a very clear overview of all of the components that are in the system, and we also document it in this way. So, yeah?
Where do you put the CSS? I didn't see it in the pages.
That's a good question. So I was still arguing with the front-end team that it would be great if we could have the CSS that is specific for a component to actually have it inside the component and add to the rest of the or built into the rest of the project CSS, but would have its contained only CSS. So that would be one step further. So at the moment we have this inside the style sheets, which is like in the global package, and then we also have the advantage of the build system that will automatically build the SAS files. So it's still in one place, but also split up in a nice way. But basically, we have the documentation of the API over here, which is just necessary if someone wants to use your component or wants to work with you on a component, needs to know how it's being called. And this also is you're also able to isolate this component as well, so you can test it individually, which is also pretty cool. All right, so the final step of the puzzle would be, this is like the page that is rendered by a route. So Iron Router loads this page up and will basically fetch some of the data and feed it into the widget. So first we get all of the activities, and then we say we render the full activity component. We pass it the current activity, and then some other parameters to make sure that the rendering is right for the widget. And we can actually reuse it here at the bottom for the archived activities, the ones that are marked as done. All right, so that was challenge number 1. Are you still with me? Still very hot? Everyone still has some water? Not fainting? All right. So code reuse. The library package that we created is basically our collection of stuff that's being reused on both the front end and the back end. And we decided to create a JavaScript namespace to access all of this shared functionality. So if there's someone who has like a better way of doing this, please contact me after the after the presentation. But we found this to be very helpful. So the usual method in Meteor is basically everyone gets their own namespace. Like you get your namespace, you get your namespace. Everyone gets a namespace, right? So you would have your Meteor, your Mongo, you would have your accounts, you would have your like all this stuff polluting the global namespace. So we thought we could just create one. We create one value inside this global namespace, and then just divide it up into a lot of sub namespaces. So we'd have the helpers, the schemas, which would have forms and entities. So you're able to check both the forms and the entities that are being stored in the Mongo database. And then basically inside a separate file, we would populate these namespaces with the specific functionality. So for here, for instance, here we have a function that's called tag input to array. So we have an input that's a string with separated by commas, and we would have the code here that would split it out and turn it into an array, which is both used on the front end to transform the data, and on the back end to translate the input into an array.
Where do you instantiate the part of dots, and then where do you instantiate all of those?
So this file, the namespace, yeah, it's done in the namespace file. So and the namespace file is.
You do all the namespaces you have in.
Yeah, and we have control because it's a package. We have control over the load order, which means that we put the namespace first, and we make sure that it exists before we fill the namespace.
So you put an underscore before
Yeah.
the namespace.
And what's very cool about this is, even kijken hoor. So what's really cool about this, which I still want to show you. So we have the namespace over here. We can always access it, which is like great. I don't know, has anyone of you worked with Angular before? Angular? Hands? Don't be shy. we were there as well. It's very hard to trigger functionality from your console. You always need to break into your controller to trigger a function. And the fun part about this one is that we basically have access to all of the shared functionality inside this lib folder. So we would actually have the client stuff over here and the language, for instance. So changing the language would actually be something like this. No, it's not something like this. Dot change, right? Guys? Yes. And we would actually translate all of the front end. I was doing this in a second, but I couldn't remember the command to get the thing open. So basically everything is English now, except for the content, of course. So the footer. Yeah, just for dramatic effect, we're going to do it again because it's so cool. But basically you would have access to this namespace everywhere. And it's also nice that you're able to inspect this as well, and you can just easily see what's going on in your code. All right. So another nice part that we have inside this lib folder is the model helpers. Has anyone heard of these? Collection helpers or model helpers? So this basically stems from the time that basically Rails made this very popular, right? So you had the fat models and the skinny controllers. So all of the functionality would be created onside the entity model. So for instance, a model would be able, so the network model would have a leave function, which you would pass a user, and you would say to the network, make sure this person leaves because I want to kick him out or something. And then the code would be bundled onto this entity, which would make sure that you would not have this code scattered everywhere in your controllers. So it's a pretty nice one. We did this a little while back, and we're really happy with this way of making sure that you do not write this kind of code everywhere over and over again. Also to check, to make sure you have like a collection and you want to make sure a user is inside this collection or another entity is inside this collection, you could just ask the collection, is this hash member with an ID, and it will just give you the answer. So we did this in this way, and I will post the slides to GitHub so you can view this at your leisure. When you create the collection, you actually create the networks, and you use a transform to actually inject these extra prototype functions into the entities. And of course, for the collection, so these were for the instantiations. So the networks themselves, you can actually see make someone leave this network. But also for the collection, we would have sort of these Rails functions, find by filter, which you could pass something and it would actually find members inside this collection, which is very helpful if you have multiple ways of accessing stuff inside your collection. We found it very useful for the part where we wanted to have some security into who's able to view certain parts of the collection. So we had like a guarded find. which is basically if you find using this method, you would check the user and check if the user is actually part of this network before you return the results. All right, so challenge number 3, which is quite an exciting topic as well. And we spent some time looking into and which we're working on as we speak. Question basically is, which is also an interesting question, business question as well, how do we decouple the app logic into separate microservices? So you can imagine that if you start your project and you're a completely green field, you basically go ahead and go your merry way inside Meteor, and you would have your accounts, you would have all of your entities in there, you would maybe even have like your processing, your cron jobs, basically all inside this Meteor framework. But this is quite exciting because you want maybe you've got some other teams who are have a specialty in Scala or have a specialty in Python or want to be able to interact with the system without completely getting into your Meteor stuff. So this was an exciting question that we had. So basically, we thought of this beautiful diagram. I don't know if everyone's able to read this. It's an early sketch of what we were going to do in the end, but it's a nice memory of the time back, and it's still quite valid. So basically, we would focus on the front-end server with the Meteor part, MongoDB, and the DDP API first. And everything we do inside the system generates an event. And this event will get sent onto a message bus, and we chose RabbitMQ because we're a little bit experienced in this. So every event that would happen in the system when a user is updated or a user is inserted or you would create a new entity, it will generate an event and emit this out, which would mean that there could be an event store or a recommendation engine or even a REST API listening to these events and emitting their own events back, making sure that we decouple all of these methods using these events. So it's a good thing that we thought of this before, because it's hard to basically pull out all of these events once you're already programming. So maybe I'll make it a little bit more tangible with some code. So basically we have our methods over here, our Meteor methods. So for instance, the archive an activity. So if you're done with an activity, you click archive and it's marked as complete. Basically you would have your normal Meteor code over here, and do the update to your local set. And after you're done doing this, you would actually emit an event which would say we archived a certain activity, and this event would get emitted outside, both inside the system and outside the system. So every time this event happens, all the side effects that happen are actually listening to this event inside our system as well. So imagine that someone is creating a separate REST API, and someone would go to this REST API and say, I would want to archive an activity. They would send the same event, so all of the side effects inside our own system are being triggered as well. So that's a nice thing that we have. So the event is emitted, and we have an handler files inside our system that actually react on these events, which will set, for instance, this is an update that gets created. So we have a timeline, and the timeline will actually show an entry, something got archived. So that's being created over here. So because this is completely decoupled, when someone else archives an activity, we can still show this behavior. Is this very weird, or I'm getting some?
It feels a little bit overcomplicated,
Mm-hmm.
I must say, but I don't know the case actually. But
Mm-hmm.
it feels like you need this when you have 10,000 transactions a second, and you need a message bus for this. But
Mm-hmm.
I can imagine you can just do it in a service worker, just basically inside your service code part, right? Or
A service worker?
well, some code is picking it up, like it's just a few lines. It's not like.
Mm-hmm.
So I was just looking for what is the reason to
Yeah.
do this.
For us, it's more that we're allowing, that we're creating a hook for another system to react to. So the main use case for this this architecture is that we would have a separate server that manages the recommendations. So for instance, this server would just listen, a new user was created, a new part-up was created, a user joined the part-up, and they would build their own like graph or Neo4j or their graph system. They would do the recommendation and they would send an event back saying, we created the recommendations for this user. So if we would not have done it in this way, the recommendation engine would have to dig into the MongoDB database, or we would have to create like an API to actually supply this data.
Already in this phase of the startup, you already need it.
That's a good question. So that would be the difference between pure premature optimization or your technical debt that you're building up.
It's elegant though, but
That's a good question. It's a trade-off. So just to be sure that another team is able to do something outside, we opted for this one.
this kind of proves that you can scale up if you need. So you need to know you know for sure.
Yeah.
And I'm really glad we decided this. Working now with different parties with the recommendation system. I don't want them inside MongoDB. So it creates options for us.
Yeah.
To scale so
Yeah.
people in your team.
Yeah?
Do you log it when some trigger doesn't work? Because I see you just return there.
Yeah.
But if the trigger is fired and it's incomplete or
Yeah.
invalid data,
Yeah, then you have a problem. Yeah, that's true. This is the downside of event-based messaging. So basically, so the question is, what happens when something goes wrong or something happens? Basically, you would maybe have like part of your method would work and some handler would fail, which would result in like some inconsistency somewhere. So in this case, we chose for decoupling over data consistency. So in any other system, maybe you do like a rollback or start a transaction and lock the database and make sure that all the parts have completed before actually committing this action.
also mean you're now just returning this first line. Wouldn't you want to know it when you get to that phase? Don't you want to transmit the event, something went wrong with this event trigger?
Yeah.
That you're aware of incorrect events?
In this case, no, but it would have been nice to log something to our logs, definitely. Yeah. True.
Another question, how is this recommendation engine or how they are connected to your platform?
It's still in
So an API or through the web API?
still on site.
Okay, that's all.
It's future, but future is now, so it's
So do you think they will have access to a specific queue or?
Yeah, it will be something like this. Yeah, so the question was, how will the other party integrate with the API? So basically, they would listen to a certain channel where we would emit the messages, and in this way, also have a place for them to get their messages in as well. All right. So we talked about this a little bit, but I had the example. So basically, a user would join a part-up inside the Meteor app. The event would be sent over a bus somewhere. A recommendation server would react to this event, do its stuff, and generate a recommendation, and basically sends out an event where we can react upon inside our system. All right, so the last challenge, scaling Meteor. And this is where a nice transition to the Scalingo. So unfortunately, we already chose for Modulus before we knew about Scalingo. So maybe we'll have to take a look at Scalingo as well. But we're actually very happy with how this is working at the moment. So maybe I can give you guys a quick preview. Is anyone here who is already using Modulus? A couple of people. That's nice. All right, so basically you go to the site, you sign up, and you can easily spin up a Meteor instance. A nice thing that Meteor has, they have support for the sticky sessions and auto scaling, which basically means that once you reach a certain peak in your CPU power, the but the platform will actually spin up another servo or another instance of your application server and make sure this load is balanced correctly without losing sessions.
Have you tested that?
Sorry?
Did you test it?
So that
Work with Meteor?
yeah, it's that it works with me. It's basically built for Meteor. So they started out as Meteor only hosting company, and they are expanding to this now. But it's like a lot of people are currently using it now. Huh?
The default to go.
Yeah, yeah. That's a tricky question, of course. We're now inside the last part of delivering, so the load tests are coming up. Are like on the board right now. You can see them on the screen board over there. Yeah. So you have some logging, and you can actually set up the scaling over there. So to accompany Modulus, we chose to use Compose.io, which is a platform for hosting Mongo deployments, which gives you the certainty that the Mongo databases are also scaling appropriately to your load. So basically, if you would go to the Compose.io phase, you would, of course, you get the fancy graphs. So this is always good, of course. But actually, it will host its own Meteor sharded environment. So you're actually able to make multiple shards of your Mongo data and ensure that retrieving and storing data is always done in a consistent way without you worrying about overloading your MongoDB instance. That's integration is like really easy because you just say, all right, instead of going to this Mongo URL, go to their Mongo URL, and you basically set up for everything. So it's a bit pricey. You pay like $18 per gigabyte of storage, but at least you have the full guarantee that it will be up and it will have very rapid reads and writes and scale up. Of course, we don't store a lot of files inside this database, so the files will be stored in Amazon or some other data store, which is cheaper by the gigabyte. So another part where I'm very proud of is the integration with Worker, which is like Travis CI. Maybe you guys know Travis CI. Worker is a startup in Amsterdam. I know these guys very well. It's a very cool team. And they made this continuous deployment platform. So what this basically means is that for this project, on each commit that is being committed to the develop branch or to any branch at all, a build is being triggered. So you can actually see that someone created a change. It will actually get the code, build the application, and run the tests. So that's a part of the work we're working on as well. And if the build passed, it will actually automatically deploy this build to an application server. So we'd actually have to deploy over here. And you could see we automatically deployed branch develop to target staging. So this basically means that every time someone commits their work to the develop tree, this work is automatically being pushed to a server, which you can immediately after like 5 minutes, 10 minutes, you can look at the staging server to actually see how your code performs in a real database. And it's even and we use this up until the acceptance environment. So when a build is marked as a, have to be inside a build. So basically when we mark a build, okay, this is ready to go to acceptance, we can actually click inside this environment and say, all right, deploy to acceptance now, and it will just fire the deployment build and automatically put the code to acceptance, which is like a breeze. So Travis is free for open source projects, and we're not open source yet. Yeah. And Worker is currently still free for closed source as well. Yeah. So they'll be coming with a pricing model, but I'm guessing that it will be sharply competitive with something like Travis CI or CodeShip or any of these other platforms. Yeah. All right. So next steps, coming to a conclusion. There's a couple of points that are still like some, how do you say this, thorns in my eye or something. Testing is still for me a bit of a struggle point. So we've had a couple of iterations of velocity tests, which is proving very nice, very good for UI testing, but actually for integration testing and testing, making sure that your methods and your backend is parsing input correctly and handling all of the unhappy cases is something that's harder to test with velocity front-end testing. So this is something that we're still looking into, and maybe still a bit also hoping that the Meteor team will give some extra effort into this backend quality as well. And we would have the DDP debug tooling. That would be nice if there would be more advancements in this area. So currently DDP is a bit of magic as well. So there's a lot of stuff happening on your WebSocket, and there are some tools that will actually show this, print this out. But it's hard to do something like a Postman tool that you had with REST calls. All right, thank you for your attention.